Hello and welcome back to the third episode of my world map tutorial series. In the last episode we've created this map texture in Photoshop and imported it so we can display it on the player UI. Today we will show the player position on our map, but before that you notice that currently our map is always visible. We want to set up a key to open and close the map, so let's start with that. We can go into our actors and BPC world map to script the functionality of hiding and showing the map here. First off, let's keep track of the current state of it. So just a variable of type boolean called visible ? And we can make that private because only this class needs to know about it. Compile and save it. Then we need a function called showMap and give it an input of type boolean called show. So if this input is false, we will hide it. And if it's true, we will show it. So this function here deals with both cases. First off, we want to check whether we actually want to change the visibility, because if our map is already visible, there is no need in showing it. To do that, we simply grab our visible boolean, and off of our input, we look for not equal boolean and connect our visible variable. Then we can hold down B and left click to add a branch, hook up our not equal to the condition. If it's false, we don't have to do anything, so we can simply go into a return node. But if it's true, we can set our internal variable to the input. And off of it, add another branch, because we need different functionality based on whether we want to show it or hide it now. If it's true, means we have to show it. So first off, you get your map reference, and off of it, set the visibility to something like self-hit test invisible. Later we'll be using our mouse to add markers to the map. So that means when we show the map, we also want to show the mouse cursor. For that, get the player controller, add player index 0, and off of it, set show mouse cursor to true. Last thing we'll do is drag off the same player controller here and set the input mode to game and UI so that our UI is able to read some inputs. The in widget to focus can be our main reference. We do not want to lock the mouse, and we will uncheck hide cursor during capture. After that, we can go into a return node. Then let's copy paste all of this for the false path. And the only things we want to adjust is the visibility will now be hidden. Show mouse cursor will be false. And instead of calling set input mode game and UI, we will call set input mode game only. Then we can go into a return node and compile and save. That's it already for this function. We will set up a key to toggle the visibility. So if the map is visible, we'll hide it, and if not, show it. So let's add a function for that called toggle visibility. And that is very simple. We just call show map. And we want to get the opposite of our visible boolean. So get it and look for a not. Then choose the not boolean and hook that up to the input show. After that, we can return and compile save this function too. By default, our map should be hidden until the player presses the correct key. So let's set that up in our event graph. We'll go to the initialize map event. And right here, before we add the main reference to the viewport, we will call show map with show being false. So we'll hide it. Right now that wouldn't work because you remember we implemented the check here that the input has to be different to our visible boolean. Currently the default value is false. So we will just set that to true only for the purpose of getting through that first branch here. All right. Functionality is now there. Let's implement a way to trigger it. And we want to do that in our player character class, so third person character. You can just right click somewhere and look for the key you want to use. I will use the M key on the keyboard for map. And here it is. Now if it's pressed, that's very simple. Just drag in your player map and call toggle visibility. Hook that up, compile and save, and we can play test. So if I hit play, our map should be hidden by default and we shouldn't be able to see the mouse cursor. Right, that's working fine. Now if I hit M, the mouse cursor is visible. I can also see the map here, so that's also working. And hitting M once more will hide it again. Alright, so that's it already for showing and hiding your map using a keyboard input. Now we can turn towards displaying the player icon on the map. And first off, we need a visual representation of our player. So luckily, if we have a look at the textures folder, you already imported the icon player from the asset pack, which we will use. And we want to display that on top of the actual map. So let's go into our world map system, then to widgets and to the w_world map. So that was the reason why we used the map overlay here, because now we can simply add the player on top of the background. And we want to start with a size box for that. Like with our map, we want to dynamically control the size of the player when zooming in and out. So that's why we need a size box here. Let's call that the player box. And check is variable. Let's also check width and height override. The default will be 60 pixel in width and height. Then we'll go to visibility, and we don't want our cursor to hit the player. So set that to hit test invisible. To add the icon, we simply add an image onto the player box. Sure it's set to fill. This does not need to be a variable because we can control everything with the size box. And for the image, simply look for icon_player. Path save. Then let's go to the event graph. Like we did for our map, we want to have two variables that define the size of our player. So let's add a variable called player size x. Make that an integer, instance editable and exposed on spawn. And then the player size in y, also an integer with the same settings, so editable and exposed on spawn. Let's compile and save. The default that we use for the size box here, where it's 60 pixel. So let's also enter that for the default values here. 60 for x and 60 for y. Then let's add a function called setPlayerSize. Of course, this needs two inputs. So first one will be an integer called 2x. And second one to y. Then we will simply set our two variables, so set player size in x to the 2x input, then set player size in y to y. And to actually make these two values do something, we need to grab our player box and set the width override. Directly after that, set the height override. And then we can drag in our player size in x, player size in y, and connect them to width and height. After that, we can add a return node and compile and save this function. On the event pre-construct, we are already setting the map size so that the size box there updates. We'll do the same thing for the player size, so set player size, and simply plug in the variables here, so player size x for 2x and player size y for 2y. We then compile save. We can head over to the designer, select our W world map in the hierarchy, and for example, we could set the player size to 80 by 80, and you can see that updating. So reset that to 60 by 60. What we're trying to do later here is control the position of our player box using the render transform and translation in x and y. So if I increase that, see our player box moving to the right, and if I increase the y, it will move downward. What we have to keep in mind though is if we set that to 0, 0, the player icon is currently anchored to the upper left corner here. So that means that every time we set the translation, we have to subtract half the size of the player box. If I set x to -30 and y to -30, this would be the behavior we want to achieve. So currently the player box is at the origin and is anchored to the center. So the center of our player image represents the actual location. All right, can reset the translation. We'll do that in code. Let's compile, save, and start doing some of the math. So we'll go to our actors, PPC world map, and then we need a function that we will call location to map position. So this will get a location from our level and convert that into the translation we use for the widget. This means it needs one input for the actual location, which is just a vector. You can call that location. And I just showed you how we anchor the widget to the center. For that, we need to know about the size of the widget. So let's just call that widget size. That will be a vector 2D. Then we also need an output of the same type, so vector 2D, you can just call that out. So this would be the translation we then have to use. And actually this function just converts something, so we can make it pure. Then for the math, let's right click our output and split the struct bin. Out X and out Y is what we get. And first off, we will get the location and convert location to map location. Then we can break the out to get X and Y. And then we want to project the X here onto a translation. And the maximum of that would be the total size of our map. So currently that's 1080 pixel. To do that, what we have to do is we divide that X by the width of the map. So this here means we get a percentage between 0 and 1, 1 being 100%, 0 being 0%. And then we can multiply that, float times float. And now we need to get the map size. So map reference and get the map size X. Hook that up and it will automatically be converted to a float. What you get here is the translation in X, where the anchor would still be the upper left corner. So we have to subtract from that. And what we have to subtract is half of the size in X. These were the minus 30 that I just showed you for the player box. So get your widget size and break it. Then we've got the X. So let's just divide that by 2 and plug it in for the minus. You can already plug this in for the out X. And the out Y is very similar, but this time we get the Y here. Also divide that by a float. And this will be the map height. Then we will multiply it, float times float, and this time off of the map reference get the map size in Y and hook it up. Then we also have to subtract half of the size in Y. So this here is the size in Y. Let's divide that by 2, plug that in for the minus node, and then the minus will feed into the out Y. Alright, let's compile and save. This function is asking for a widget size, and later this will be modified when zooming in and out. So it makes sense to store the original size of your player in a variable, and that is exactly what we will do now. Let's add a variable, original player size, that is called, of the type vector2d, so we can store both X and Y. And let's make that private. We need to set this on event begin play because that is when we haven't messed around with the size yet. So let's go to the event graph, and maybe before we show the map, we will set original player size. Off of it, we will make a vector2d, and then to grab the X and Y, drag in your map reference and get the two variables. So player size in X and player size in Y, and hook both of them up to the make vector node. Compile and save. Then we need another function called update player position on map. And now that is very simple. We just get the map reference, then get the player box and set render translation. To get this translation, we simply call location to map position. Location will be the player and then get actor location. Hook that up. And for now, the widget size will simply be the original player size, because currently we haven't implemented zooming yet, so we cannot change the player size. Hook that up to the translation and then return. The question now is, when do we have to call this function? So when do we want to update the player position? And first off, we only ever want to update if our map is visible at all. And then we want to do it either when the player moves or when we start showing the map. Everything else would just be a waste of performance, because either you're updating while the map isn't shown at all and doing calculations that no one sees, or you're updating the position even though it doesn't change because the player doesn't move around. Let's start with updating the position when showing the map. So let's go to show map. And here on the second true path, right before we go into the return node, we'll call update player position on map. And then connect the return node again. Compile save. After that, we want to handle movement of player. So let's go to the event graph. And here we will add a custom event called onPlayerMoved. Like I said, we only want to update if the map is shown. So get visible, and off of it add a branch. Then if it's true, simply call update player position on map. Save. functionality for updating is there now. We still need to call this onPlayerMoved event, and that we can only do from within our third-person character. Open Blueprint Editor, and here you've got two input axis events, move forward and move right. Problem with axis values is that this event here is also called when the axis value is 0. So what we would do here is search for a not equal float and just leave it at 0, then add a branch. And only if it's not equal, we can grab our player map and call onPlayerMoved. Then let's copy this and paste it for move right. Hook up the axis value, and that should already be working. So let me quickly go into play mode. If I hit M, you can see the position of our player. Now if I move around, that updates perfectly. I can hide the map again and go somewhere completely else in the parkour. So maybe here on this platform. And if I hit M, the position should also have updated, which it did. There's only one issue currently, and that is if I move somewhere and then try to jump, it won't update. So I hit jump, and now if I move, it snaps to the new location. This issue makes perfect sense, because if we're jumping, this input axis move forward is not necessarily called, only if we hold down WASD while jumping. So let's fix this issue by going to our BPC world map, and let's add a variable here called jumping. Question mark. Boolean should be fine, and let's make it private. Then let's search for some empty space and add a custom event, which we will call onPlayerJump. And what we will do is set jumping to true. Then we want to check whether we want to update on our map. So we need to see whether our map is visible. Add a boolean. And if it is, we will set a timer by function name. So we will simply say, if we're jumping, we will update the position in a defined interval. So for example, every 0.5 seconds or so. And then when our player lands, we can stop this timer again. The object to execute the function will be self. The function name will be update player position on map. You can hit F2 and Control C to copy this, then paste it into the function name. If you just do a little spelling mistake, it already wouldn't work. We will check looping because we have to call this more than once. And let's promote the time to a variable called in-air update rate. So after how many seconds do we want to update when our player is in the air? Let's make that editable, expose on spawn, and put it in the settings category. If we then compile and save, we can enter some default value. I figured out that something like 0.05 works pretty fine. So this way it would be called 20 times a second and looks somewhat smooth. We can later play around with this value. And we want to grab the return value here and promote that to a variable called update timer handle. That way we can later get this timer handle and stop it. Let's also add another custom event here called start timer and hook that up to the set timer by function name. If you're wondering why we need that, there are some cases where we want to set the timer even though our player didn't jump. For example, when our player jumps while the map is not visible, we wouldn't start the timer, but if you then open up the map, we would still have to update, so then we would call the start timer event. We also need the last custom event here called onPlayerLand, and what this will simply do is set jumping to false. We want to see whether that timer is playing, so get update timer handle and look for is valid, then add a branch and hook that up. If that is true, we can stop it, so grab it and call clear and invalidate timer by handle. And then we will also call update player position on map one last time here. Okay, now when we change the visibility of our map, we might want to start or stop this timer. So let's go into our toggle visibility function and let's move the return node to the right side. After we show the map, let's add a branch. And we want to check whether we are now visible and jumping. Look for an AND condition, plug in jumping and connect that to the branch. If both of them are true, we have to start the update timer. So start timer and then go into your return node. If it's false, we can go into a second branch. And now we want to check whether visible here is false. So look for a not. And whether our timer is still playing. So get the update timer handle, look for is valid, hook that up to the end and then the end to the condition. So did we hide the map, but our timer is still playing? And if so, we can simply copy that over and clear and invalidate timer by handle again. After that, go into return node. And let's copy that for the false path pile. Save. That's it already for the functionality. Right now, the two events here on player jump and on player land are not called. So we can hop back to the third person character. And luckily, there are some default events provided by the engine. So let's just look for event on jump. And there should be something like event on landed here. Then simply drag in your player map and call on jump and on player land. Let's compile, save and see if that's now working. If we hit play, there it is. We can hit M. Currently everything is fine. Now I jump and it's still updating perfectly. And if I jump here, that also works. Alright, that's the end of this episode. In the next one, we'll handle zooming in and out. So see you then.